put 1. Again, what is this number? Notice that it's the first one, it's outside of our interval. Don't panic yet. So it is possible that the first, maybe even the second, could be outside of the interval. So what does this number represent? The 2.8304877722. What does it represent?
X sub 1.
Yes. Now x sub 2, from this moment on, I just copy, and I make sure that I always have the previous answer inside. So the calculator will put this in, and then the next one in, and then the next one, as long as I want. Okay, even x sub 2, which is 2.049555245. Don't panic just yet. Okay, 2 of them are outside of the interval. We did not expect that, but it's okay. As long as not 1,500 of them are outside, we are okay. Aha, good. So x sub 3 is getting closer. 1.938656127. And then I repeat. And then x sub 4, 1.934568962. It will stabilize soon. Okay, so x sub 5, 1.93. So we have 5 digits already. 934563211. And the next one should be completely identical. And that's what it is. So there is no need to copy another one. So they wanted 6 digits. 246, here's the number. But you should always copy the whole thing. And that's Newton's method. You will encounter some problems like, of course, like this in WebAssign. It's okay if you only solve for one solution. Just remind me and I'll give you the points for the rest. So if it's asking you to find 4 solutions for a problem, no, I only want 1. And I'll give you the points for the rest. One of them is good enough. So this
What
is...
does that mean?
So WebAssign will give you an equation and it will say find 4 solutions. I don't want you to repeat the process. Just find one. Put that one solution in.
Oh.
I don't want you to repeat 4 times, and I'll give you the points for that assignment. I can't go around that.
Like 4 different intervals.
Yeah,
right?
no, yes, exactly, and 4 solutions.
Okay.
And 4 solutions. I don't want you to repeat that 4 times. There is no need for that. Okay, any questions? Okay, so let's see what is left from this chapter. We have to go back to 4.4 for L'Hopital's rule right now. We're going to start. We have about 10 minutes left. And the only one section that I have not touched on yet at all is 4.7, optimization. So we're going to look at that on Thursday. And what is the remainder? And next week, we're going to review for the test. So I'd like now to go back to L'Hopital's rule 4.4. And we discussed that, but we didn't see them yet. 7 indeterminate cases. So here they are. Ratios. We have 0 over 0 and infinity over infinity. We have one difference. These are the only ones we've seen before. We have one product. And you can say, wait a minute. I understand that you don't know what this is, because this could be very small in comparison or very big in comparison, by comparison. But you can't say this. This is clearly 0. No, it's not. It's not. This is another indeterminate case. And we have 3 powers, which are the most cumbersome to work with. These are the nicest. This is okay. This is very easy to manipulate the function a little bit, and this will turn into one of these two very easily. So this is okay. This is the best. These are the best. This is okay. This is not difficult because it can be changed into this, but the 3 powers are the most cumbersome. So 0 raised to 0, infinity raised to 0, and 1 to infinity. You can say, wait a minute. 1 to infinity? Yes, it's an indeterminate case. So 1, 2, 3, 4, 5, 6, 7. The powers are the most cumbersome to work with. Okay, so let's go back to, let me share my screen. Where are you guys? I can't see. Okay, I found you. Okay, so here, I don't think we need to practice this today. I would like to, because we only have less than 10 minutes, I would like to practice this one. And then we leave the most difficult ones for Thursday. So we're going to look at 0 times infinity. Okay, I'm on page 13. So, okay. Good one. 44. In 44, we have limit as x approaches infinity from the square root of x and then multiply by e to negative x over 2. Okay, so we are asked to find this limit. Remember, L'Hopital's rule is all about limits, right? I forgot to mention that again. We discussed that. So L'Hopital's rule has to have a ratio, has to have this intermediate or initial step of 0 over 0 and infinity over infinity, and then we can differentiate the top and differentiate the bottom. Okay, it's all about limits. Okay, so let's take a look at this. When we're asked to find the limit, what is the first step we need to perform? Always and forever. Anyone, please?
Plug it in.
Yes.
Plug it in.
Yes. So we have to analyze each piece. Where is this going? Where is the tendency of this function when x approaches infinity?
Also infinity?
Absolutely. It doesn't matter what. It has to be infinity. Good. Forget about this piece right now. Remember, we have to start with the inner. First, where is this piece going? Where is that piece going when x approaches infinity?
Negative infinity.
Correct. And where is e to, I shouldn't write this, but I have to explain. Where is e to negative infinity going? And always remember, you have to perceive it like this. Where is this going?
0.
Yes. So we have an indeterminate case of 0 times infinity, or infinity times 0 is the same thing. Okay, so this particular situation can be easily dealt with an algebraic manipulation. What does that mean? Change the function a little bit. Make it look differently, but not change the function. So I'll continue jumping over all this from here. And I see that this has a negative power. I'll leave the square root alone and bring it to the denominator with positive power. At this point, the function is the same. This product or this ratio are exactly the same because e to negative x over 2 can be written as 1 over e to x over 2. But now I accomplished my target. I got to my target because I have infinity over infinity. And these are the only situations in which I can use L'Hopital's rule. So I got infinity over infinity. Yay! So if that's the case, then I'll say limit as x approaches infinity. Can anyone differentiate the top? And can anyone differentiate the denominator? Remember, two conditions. Limit, 3 maybe. Limit, ratio, and infinity over infinity or 0 over 0. All conditions are fulfilled for L'Hopital's rule. So can anyone differentiate the top? We never differentiate like that, but inside the limit, and when it's infinity over infinity and 0 over 0, we can. So can anyone give us the derivative of the square root of x?
1/2 x to the negative 1/2.
Very good. Awesome. Can anyone give us the derivative of e to x over 2?
1/2 e.
Yes.
To,
Yes, e to x over 2 times the inner function prime, which is 1/2. Perfect. Awesome. Now I'm going to rearrange this. I don't like fractions over fractions. Nobody does. So x approaches infinity. The top is 1 over 2, the square root of x. I flip 2 over e to x over 2. I simplify. And now I try again. Let me write it one more time. So limit. Remember, we do not drop the limit operator. We have not applied it yet. So now can anyone tell us where is the numerator going?
one.
Good. Can anyone tell us where is the denominator going?
Infinity.
Yes. Can anyone tell us where is 1 over infinity going? And now we can drop the limit operator.
0.
Correct. You can say, see, I told you. No, no, by chance, it happened that it's 0. Please do not ever conclude, oh, very easy, no problem. 0 times infinity is 0. No, you're not going to get that too often.